So in our 7.4 notes, properties of logarithms and natural logarithms. First thing that I want to talk about is the natural logarithm. I want to get that kind of out of the way right now because it's really not a difficult thing. It's a little new notation, just kind of like the common log, right? The common log was log base 10, right? Remember that. The common log, log base 10 of x, we just said we wrote that as log x, right? If there's no base, that means it was base 10. Called that the common log. Well, today we're going to talk about the natural log, which we have actually already worked with. We just didn't use the proper notation for it. Okay? The natural log is log base e. Okay? Log base e is the natural log. And therefore, we're going to rewrite that. And again, it probably goes back to Latin. It seems like everything in mathematics and science always go back to the Latin name of things. Okay? But for whatever reason, natural log is abbreviated ln. Okay, so to help me remember it, I always thought lateral nog. Okay? Think lateral nog. It's the natural log. That's why it's ln. So ln, okay, is for natural log. And what is ln? Well, it's log base e. Okay? Log base e. E being that special number, the Euler number, 2.72. Okay? It's called E because mathematician Euler discovered it, or got credited for discovering it first. And even though his name sounds like it starts with an O, it actually starts with an E. It's E-U-L-E-R. That's how you spell Euler. Okay, and so it's the Euler number, the Euler constant, and so they use E.
Why is it a special number?
All right, so the only thing new there is just natural log being log base E. We've dealt with log base E in homework before. We just haven't dealt with the notation for natural log, and that's just ln of x, okay? So it's natural log of whatever you're taking that logarithm of. All right, so now that we've talked about that, I do want to talk about the properties of logarithms, and that is in the box right above where we're at. Okay? These properties of logarithms should actually be fairly familiar because they're really the properties of exponents. Remember I told you guys before that the logarithm, that was the first sentence we wrote down, right? A logarithm is an exponent, right? The logarithm is the exponent. And so we're really using the rules of exponents here for logarithms. All right? We said that if we were multiplying two things that had the same base together, what did we do to the exponents? Remember rules of exponents, if we're multiplying two items that have the same base, we do what to the exponents? Add them. Well, look what's happening here. We are taking log base b of m times n. We're multiplying, so we can break m and n apart into two logarithms added together. It's really that same concept for rules of exponents. If you're multiplying, you add the exponents. Well, remember, logs are exponents. So we're multiplying here, so therefore we're adding logarithms together. They keep the same base. So log base b of m times n gives us log base b of m plus log base b of n. Okay? Same thing with the quotient property. We said before, if we were dividing two numbers that had the same base, we would then subtract the exponents. Same thing goes here. We're dividing two items, and so therefore we're going to subtract the logarithms. And it's always the top minus the bottom. So we have log base b of m minus log base b of n. Okay, so those follow along with our rules of exponents fairly well. Division goes with subtraction. Multiplication goes with addition. Okay? The new one, it's new, it doesn't seem like it goes with our exponent rules, but it's still not terribly difficult here, is if we have log base b of m raised to the n power, you can take that exponent and move it out in front and make it become the coefficient of the logarithm. And so rather than log base b of m raised to a power, it's now that power times log base b of m. Okay? You just take that exponent and you move it out in front and make it become the coefficient of the logarithm. So there are the three properties of logarithms so that we know how to work with them. We can manipulate them. We can use them in equations if we have to, which we will be doing in the next section. And actually, we have dealt with the first property already in class. We've worked problems like this, but I didn't show you the property yet, and so therefore you wouldn't have recognized it. Okay? So let me show you that example. This is problem number 67 from, I think it was assignment number 50. So a book assignment a couple days ago. I believe it was last Thursday's homework assignment. We were graphing logarithms. And number 67 said y equals log base 2 of 4x. Okay, and so we went through and we worked it that way. Okay, rewrote it in exponential form. And then we had to divide both sides by 4 to get x by itself. And then we plugged in for y and graphed it. Wonderful. Well, what I see here, now that we're talking about properties of exponents, or properties of logarithms, excuse me, is that I've got the log of two things multiplied together. So according to our new properties today, how can I break those apart? Multiplication goes with addition. So I can break that apart. So I'm going to go over here in the next graph over, and I'm going to take y equals log base 2 of 4x, and I'm going to break it apart and say that we have y equals log base 2 of 4 plus log base 2 of x. Okay? So looking at that, there's a little quiz to see if you guys have been paying attention to how to work these problems. What does log base 2 of 4 equal? Log base 2 of 4 equals 2. Because you're asking yourself, 2 to what power equals 4, right? So therefore, log base 2 of 4 equals 2. So we have y equals 2 plus log base 2 of x. Well, I can flip those around and say that I have log base 2 of x plus 2. All right, well, looking at that problem, that tells me that we have a shift going up 2, right? We have a shift going up 2. So I now want to graph this, because remember I plot points without shift. So rewriting that as 2 to the y power equals x, making my t-chart, which if I remember correctly, this t-chart's going to be long, so I'm going to make another extended t-chart there. And we're going to plug in -2, -1, 0, 1, 2, 3, and 4, I believe is how far we can go. So let's see here. 2 to the -2 power, what do we get? 1/4. 2 to the negative first.
1/2.
2 to the 0.
1.
2 to the first.
2.
2 squared.
4.
2 cubed. 2 to the 4th power. 16. Okay? So maybe we couldn't have gone to 4, but we have it on there anyways. All right? So now I want to plot those points. So I'm at 1/4 on the x, down 2. 1/2 on the x, down 1. 1, 0. 2, 1. 4, 2. 8, 3. But each one of those points needs to get shifted up 2. So up 2 goes here. There, 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 and there. So our graph is this. Right? Okay, so we did all that work, and it's the exact same graph we had from the previous assignment. Okay? As they should be, because I told you they're the same equation. They're the exact same thing. All right? That equation is the same thing as that equation. Because our properties of logs, I wouldn't tell you they're properties if they weren't actually true. Okay? So they will work. Every time. You could rewrite that multiplication as an addition problem. Questions? So let's take a look at work. And we'll start out with our first example up here, the natural logs. Remember, ln means natural log. It's log base what? Log base e is the natural log. So we have 2 natural log of 15 minus the natural log of 75. Okay? 2 natural log of 15 minus the natural log of 75. That's how I would say that. That's how I would read that. So the first thing I see is that we have a coefficient out in front of that first natural log. So looking at those new properties, those 3 properties, what can I do with that coefficient? It's the third property, by the way. I can take that coefficient and do what with it? It's already in front of the log. Work backwards. I can write it as the exponent. I can write it as the exponent of 15. It goes to that first logarithm right there. So I have the natural log of 15 squared minus the natural log of 75. Okay, well, next, I have the natural log of something minus the natural log of something. How can I condense logarithms if they're subtracted from each other? Look at you. What are we doing? Division. Yeah, subtraction and division go together. So therefore, I can write this as the natural log of 15 squared over 75. So now I have it written as one logarithm, but I need to go through and simplify it. I need to go through and simplify it. So, to simplify this, you could go through and say, okay, what's 15 squared? And 15 squared is 225, and then go ahead and take 225 and simplify it by 75. You could do that. Personally, I think it's easier in my head, it's easier for me to see if I write it as 15 times 15 over 75. Because then I see that 5 goes into 15 3 times, and I know that 5 goes into 75 15 times. And the 15 then cancels with the 15 on the bottom. So I'm left with 3. So the natural log of 3. And that's our answer. All right, let's try some more here. Let's go down to example A here. We're simplifying logarithms. Another way of saying simplifying logarithms, you might see instructions on a quiz or something saying condense. Condense the logarithm, condense the expression. We want to condense this into one logarithm. Okay? So I have log base 4 of 32 minus log base 4 of 2. So again, I've got subtraction, right? I've got log base 4 of this minus log base 4 of that. That is going to give me log base 4 of what? Subtraction implies division. Look at your rules at the top of the page. This is 32 divided by 2. You know, and it might help keep it straight for you guys in that the division bar kind of looks like subtraction. Right? It kind of looks like a subtraction bar. So keep those together in your head. Yes, in order to be able to condense these, the base has to be the same. They have to be the same logarithm. Okay? All right, so now we have this. Well, what is 32 divided by 2? 16. So we have log base 4 of 16. But wait a minute, I think we can evaluate that, can't we? Log base 4 of 16, what does that equal? 2. For those of you wondering why that equals 2, remember we think to ourselves, 4 raised to what power equals 16? Okay, and the answer is 2. So 2 is the value for that logarithm. Let's try another one. Let's look over here at example B. Example B looks like there's a lot going on in this one. Okay? But the first thing that you should be worried about, are the coefficients. We cannot combine the addition until we've taken care of the coefficients. Okay? Because our rules at the top of the page, all those rules are for when the coefficient is a 1. When there's one logarithm. Okay? Not 6 logarithms. So we got to take care of those coefficients first. And what do we do with those? Move them to the exponent. We move them to the exponent. So this 6 becomes the exponent for the x. This 5 becomes the exponent for the y. So we have log base 2 of x to the 6th power plus log base 2 of y to the 5th power. Little side note for you guys. Please think back to grade school when they gave you lined paper. You really need to be practicing writing logarithms just like you were in grade school with lined paper. Okay? Because you've got to know a lot of you are getting sloppy with how you're writing these, and therefore you're writing them wrong and therefore thinking about them wrong. Okay? This was log base 2 of x to the 6th power. Okay? It is not 2 to the x power, though some of you write it that way. It is not log of 2 times x. Okay? This is like the reference. It's telling us what logarithm, what base for our exponents are we talking about. We're talking about base 2. Okay, we're thinking about base 2. All right, and then the x is what we're taking the logarithm of, and the x is raised to the 6th power. Okay, so we really got to practice our notation so that we can think about it the right way. Okay? So, let's go back. Log base 2 of x to the 6th power plus log base 2 of y to the 5th power. I've got the log of this plus the log of that. I can combine these into the log base 2 of what? X to the 6th power times y to the 5th power. Addition can be condensed using multiplication. There's no way to simplify that, and so this is our answer. Log base 2 of x to the 6th power times y to the 5th power. It would not be considered wrong if you put parentheses here. If you wanted to say that, that would be fine too. That's just extra clarification. Okay? So, let's go through and do this then in the other order, okay? We've done what's called condensing or simplifying logarithms. Well, what about expanding logarithms, okay? We want to expand this logarithm. We want to draw it out as much as we can. So, first things first, we see what? What operation's going on inside that logarithm? The quotient, yeah, division, right? So I've got 4x divided by y. So how do I break that apart? Subtraction. And yep, go ahead and keep saying it.
Log of 4x minus log of y.
That's exactly it. Log of 4x minus log of y. I got a quick question for you. They don't give me a base on that. So what's my base? 10. Base 10. Thank you. That's the common log. Log of 4x minus log of y means log base 10 of 4x minus log base 10 of y. Okay? So, common mistake. Students do this and do this perfectly, but then stop. You think you're done. You are not done. Because 4x means 4 times x. That's multiplication. How do we break apart multiplication? With addition. We have got to break that apart into log 4 plus log x minus log y. Now the last thing that we should pay attention to is that log 4. Can I simplify that down farther? Yeah, but you got to be careful, because what's the base of my logarithm? 10. So I'm asking myself, 10 to what power equals 4? It can be done, but not easily with the way we've learned up to this point, right? Yeah, that's not going to be an easy one. That's going to be some fraction, some decimal, some crazy number, right? So we stop right here. So looking at this problem, first thing we see is the quotient, the division. So breaking that apart, we use subtraction. Please remember that subtraction kind of looks like the fraction bar, so that's how you kind of keep it straight. So we have log base 9 of x to the 4th power minus log base 9 of 729. It is very important that you guys write this properly. Again, go back to thinking in grade school. Lined paper. Okay, log base 9 of x to the 4th power. Log base 9 of x to the 4th power. That does not say 9 times x to the 4th power. Some of you are being sloppy in writing it that way. Your base is written too big, and so it looks like 9 times x. Or some of you are thinking that it's 9 raised to the x power. It is not 9 raised to the x power. This is an operation. This is telling us what base we're thinking in. We're thinking in base 9. Okay? And then we're taking the log of x to the 4th power. So our next step should be to take care of that exponent. This exponent on the x can be brought out in front as a coefficient of the logarithm. 4 log base 9 of x. Again, that is not 9 times x. It is not 9 to the x power. It's log base 9 of x. Okay, so we have that one done. We can't do anything more with 4 log base 9 of x. But what about log base 9 of 729? Nope, not 9 squared. 9 squared is 81. 9 cubed is 729. So therefore, what does log base 9 of 729 equal? 3. That is our answer. Okay? Remember, when we were going through and working these types of problems, because this was, a quiz problem from the other day, we would go through and say, all right, well, what does that equal? Then we'd rewrite that 9 to the x power equals 729. And I told you guys that, yes, even though we would go through and do this and say, okay, x equals 3, that really what we were doing is simply saying that log base 9 of 729 equaled 3. Right? Because there really wasn't an x in the problem. And so that's all we're doing now. We're saying this is that. All right, so make sure that you're paying attention to what you're doing and rewriting it properly.